Okay, so this is the next question. The question is, what is the largest order of an element in the group of permutation of 5 objects? So go through this question and answer it. Let us see how to get the correct solution when we come back. Now for this question we are going to be considering S5, which is nothing but the symmetric group on 5 elements the meaning is that contains, or I would say that consists of all possible permutation of the set. Okay, so if I were to take S5 equal to 1, 2, 3, 4, 5, then this S5 will contain all possible permutation of these elements 1, 2, 3, 4, 5. Now, having mentioned this, let me go and bring in the concept of cycle. Now, what is a cycle? You have to know. Now, this is actually a permutation that affects the targeted elements in the set. So this would actually create the rule-based mapping for the elements in the set. So let me give an illustration. Say for example, if I want to create a 5 cycle permutation for S5, or I would say on S5, then my sigma is going to be 1, 2, 3, 4, 5. This is the 5 cycle permutation. Now the question is, how many times should we run this operation on the set? Okay, so let us see. To begin with, I'm going to run this on S5 one time. So what does it do? This would actually map 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 1. So our new S5 would now be, see, we started S5 like this 1, 2, 3, 4, 5. Now our new S5 is going to be 2, 3, 4, 5 and 1. This is all because that we ran this cycle. So what does this cycle do? This cycle is actually targets all the elements of S5. Okay, and to put it in basic words, this will cycle all 5 elements in the particular order, or the order that we are setting it up. Okay, so in this case it's simple. In this case 1 is basically going to 2, 2 goes to 3, and so on and so forth. This is by running sigma once. Now the second application, the second time, let me write that down. Second application of 1, 2, 3, 4, 5 squared will produce my new S5 to be as 3, 4, 5, and then the next element is going to be 1 and 2. So this is my new S5 when 1, 2, 3, 4, 5 raised to the power of 2 is operated on S5. Okay, now the third application of 1, 2, 3, 4, 5 raised to the power of 3 will produce a new S5, which is going to be 4, 5 and 1, 2, 3. Okay, hope you're watching. So moving on, I need to proceed to show you what happens when 1, 2, 3, 4, 5 is executed for the fourth time. So when this happens for the fourth time, my new S5 is going to be 5, 1, 2, 3, 4. Okay, now for the fifth time, 1, 2, 3, 4, 5, when it runs to the fifth time, my new S5 is going to be 1, 2, 3, 4 and 5. So we are getting the original set back. So what is the number of times we ran sigma? How many times did we execute or perform the operation on an S5? We performed it as 5, so that's why we call it as 5 cycles. Now what exactly does the question want us? The question wants us to find the order. So what exactly does this mean, find the order? It means we have to find the largest k such that sigma raised to the power of k is equal to E, identity. Okay, now when we say identity, we are getting the original set back. So in this case we ran 1, 2, 3, 4, 5 times to get the original set back. So the question wants us to find the largest k. Now in this case we do not know if 5 is the largest value for obtaining the set back. We do not know that. So that is exactly what the question wants. Now how do we find that? So that is the all important question, right? Now as I mentioned to you, in the first case I took sigma to be as 1, 2, 3, 4, 5. Now this has got 5 elements, 1, 2, 3, 4, 5. Okay, so the split is just 5 because the original set has got 5 objects. We have 5 here. Now what if I split this sigma as 4 and 1? So in this case sigma is equal to 5. So this is also possible, right? I can have a 4 cycle and then follow it up with a 1 cycle. I can also have 3 cycles and 2 cycles. I can also have 2 cycles and 1 cycle and 1 cycle and 1 cycle. I can also have say 2 cycles and 2 cycles and 1 cycle. And I can also have 1 cycle, 1 cycle, 1 cycle, 1 cycle and 1 cycle. So all these cycles are possible. Now the all important fact is we are actually looking for this maximum value, K should be maximum. Okay, so the order of the cycle is required. Order of cycle, that is actually obtained by LCM of cycle length. So this is the formula, LCM of cycle length. Now in this case, what is the LCM here? LCM, so this is going to give me the order. LCM of 1 2 3 4 5 cycle length. This is the length of the cycle. What is the length of the cycle? Let's say 5. So LCM of 5 is going to be 5. Over here we need to get the LCM of 4 and 1. So what is the LCM of 4 and 1? We get 4. Now next is LCM of 3 and 2. So what is the LCM of 3 and 2? It's 6. And LCM of 2 1 1 1. So what is the LCM here of all these elements? 2 and 1, it's going to be 2. So LCM of 2 and 1, again it's going to be 2. Now in this case, LCM of all 1 1 1, the LCM of all these elements is going to be 1. Of all these, which is the largest number that you can see here? Obviously 6. So the maximum K value that can run cycles on the symmetric group has got an order of 6, and the split is 3 2. So you can also have 2 and 3. So that is the conclusion for this particular question.